Hello chemists and welcome to Bale's Chemistry. In this walkthrough I'm going to look at a question which involves calculating the pH of a buffer formed by combining a solution of weak acid with a solution of its salt. Now there are quite a few steps to go through in this calculation. We're going to start with calculating the moles of HA, then the moles of A-. Now we've got a new volume because we've got two solutions being combined together, so we've got a new total volume which will allow us to work out a new concentration. Once we have the new concentrations of both HA and A-, we can use the Ka expression to get a concentration for H+, and then we have that, we can use the pH expression to work out the pH using the concentration of hydrogen ions. Let's have a look at how we did it. Okay, so in this walkthrough we're going to look at calculating the pH of a buffer solution made by adding 6 centimeters cubed of 0.5 moles per decimeter cubed ethanoic acid to 35 centimeters of 0.6 moles per decimeter cubed of sodium ethanoate. One of the biggest things here to remember with this example is that we're going to have a change in volume, because we're adding two solutions together, so we need to recalculate their concentrations once they're combined to have the concentrations that we're going to use in the Ka expression to work out the hydrogen ion concentration and then to work out the pH. So we're going to start off by working out our new concentrations, and to do that we're going to work out the number of moles of HA or ethanoic acid, and we're going to work out the number of moles of A- to start off with. So we'll do 60 divided by 1000 because we've got 60 centimeters cubed of HA, and we're going to multiply that by 0.5, which is the concentration of the ethanoic acid or HA, to get us 0.03 moles. And for A-, that's the ethanoate ions, we've got 35 centimeters of those. We'll divide that by 1000, and then we'll multiply that by 0.6, which is the concentration of sodium ethanoate ions, to get 0.021 moles. So we're now also going to need a total volume, and to do that we'll add our 60 to our 35, divide that by 1000, to get a value for our volume of 0.095 decimeters cubed. Now we've got that new volume, we can work out the concentration of HA by taking the value we had before, which was 0.03 moles, dividing it by 0.095 to end up with a concentration of 0.31 moles per decimeter cubed, and a concentration of A- to be 0.021 divided by 0.095 to give us a new concentration of 0.221 moles per decimeter cubed. Now we have all those values, we can look at starting to calculate a concentration of H+, which is what we need before we can do a pH calculation with minus log. So now we've got that set up, we're going to use the Ka expression, remembering that Ka is the concentration of H+, multiplied by the concentration of A-, divided by the concentration of HA. So we'll rearrange that to get H+ as the subject, which will give us concentration of HA multiplied by Ka divided by concentration of A-. So put the numbers into that, and we've got 1.5 times 10 to the minus 5 for Ka, multiplying that by 0.31, and then dividing that by 0.221 to give us the concentration of hydrogen ions as 2.10 times 10 to the minus 5. Now we have that value, we can work out pH, and pH equals minus log of the concentration of hydrogen ions. So we'll do minus log 2.10 times 10 to the minus 5, which equals 4.67. That's it for this walkthrough. Hit the like button if you found it useful, and thanks for taking the time to watch.